Okay, you guys, we were doing problems about analyzing trigonometric functions. This is the function we're analyzing, and in the first part of the video we checked the transformations, and using the transformations we did the scale of this function, and we got some information like domain, range, minimum, and maximum. In this video we're going to see how to do the graph, because doing graphs for me it's a very good skill. You should have this skill even if you don't going to work in math anymore. The skill of doing graphs and see scales is very important, because every time you can see a graph in newspaper, or you can see a graph in the TV, or you can see a graph in your work, or you can see a graph anytime. And this is why I think this is very important. So we're going to sketch this graph. We saw the transformations, and with the transformations what we notice is that the new scale starts at negative 11 pi halves and goes to pi halves in x, and in y is going from negative 3 to 7. So what we're going to do is to do the sketch using those scales. So what I did here down was the Cartesian plane. Remember that in the Cartesian plane this is going to be x, the domain, and this is going to be y, or fx, the range. So what we're going to do now is to do the graph. Notice that I divide 1 squared is pi halves. So as we have negative numbers, I go until negative 11 pi halves and go until pi halves as we have here. Okay, as we have in the red parts here. So now we're going to set the points. Look at that, pi halves. Pi halves is this point that is going with 2. So let me change to blue. So pi halves with 2. Now let's see the other point. The other point is pi, negative pi, you can see it here. And pi goes with this number here, that is negative 3. Okay, so negative pi with, where is it? I don't see it. What happened to you? Okay, I'm sorry. So negative pi goes with negative 3. Now the next point. The next point is 5 pi halves, that is here, that goes with 2. So 5 pi halves goes with 2. 5 pi halves goes with 2. The next point is negative 4 pi. So negative 4 pi goes with 7. So 4 pi with 7. And 11 pi halves goes with 2. Goes with 2. Negative 11 pi halves goes with 2. Okay, so in this way we can see that the graph, our graph is, I would like to see what is the line that we're doing. Okay, so this is the graph, the sketching of the graph. Okay, obviously this is going to continue, but look at that, every 3 squares in my scale you have to reach or a minimum point, or 2, or a maximum point. Minimum, 2, or maximum point. So at these 3 it is supposed that you're going to get to negative 3, so on and so forth. And here each 3 you have to reach a maximum then in the other 3 you gotta pass by 2, and so on and so forth. Okay, this is something very important. In the last time we found the maximum points, negative 4 pi plus 6m pi using the period, and in this case the only thing that lasts is the intercepts. Notice that the x-intercepts here are here, okay? In this part are these two x-intercepts, and the others are just addition of the integer numbers of the period. So we just need to find these two x-intercepts. Notice that here the x-intercept is kind of 0. We don't know if it's 0. And the y-intercept is kind of 0. We don't know if it's 0. So we just need to find it. So let's first find y-intercept. So y-intercept. The y-intercept, remember that the y-intercept is when the function is 0. So it means that the function in 0 is just negative 5 sine of 1/3 of 0. So we can skip it. Pi 6 plus 2. Okay, and the sine of pi 6 is a half, so 5 halves plus 2, and this is just 5 halves plus 2. This is we can write it as 4 halves, so this is going to be minus 1 half. So the y-intercept is minus 1 half. Okay, that's the y-intercept. So if we're very strict with our graph, actually the sine function should pass by this point. So we should do it, instead of this blue, we should do it like this. Okay, this is the way to do it, because it's fx minus 1 half. And now we're about to find the x-intercepts, you know, the x-intercepts. This is the y-intercept, so now we're going to find the x-intercepts. To find the x-intercepts, we just need to set the function equal to 0. So x-intercepts. X-intercepts. We just need to set fx equals to 0. So 0 equals minus 5 sine of minus 1/3 of x plus pi 6 plus 2. Okay, so we're going to find the real zeros of x. So we're going to start solving by subtracting by 2. Okay, remember that the sine function is a function, not a multiplication, so there's no distributive property or something like that, or divide by sine. What you can do is divide by 5 to get 2/5 of sine of negative 1/3 of x plus pi 6, and here we're going to apply the inverse sine to get inverse sine of 2/5 equals negative 1/3 of x plus pi 6. So now we're going to subtract by pi 6 inverse sine of 2/5 minus pi 6 equals negative 1/3 of x. Now let's multiply by negative 3. So if I multiply by negative 3, it will be minus 3 inverse sine of 2/5 plus 3 pi 6 equals x. And just to rewrite x equal, this will going to be pi halves minus 3 inverse sine of 2/5. Okay, if you set this information in the calculator, remember to put the calculator in radians, but if you put this information in the calculator is going to tell you just one answer. And notice that in the graph we have two answers, two different answers. This, and this. Okay? So the calculator is just going to tell you one answer because the calculator just used the inverse sign between minus pi halves and pi halves. This is the domain of, we're going to use A, of the calculator. Okay, so if you put on your calculator, inverse sine of A is gonna get you a number from negative pi halves to pi halves. So in this case, as you have sine, remember that in the unit circle approach, sine refers to y coordinate, and for every angle on the unit circle there are two angles for which the sine is the same. In this case is this angle and this angle, and in this case is this angle, and this one. Okay, so we have two options. So in this case, let me do here like a very kindergarten Scrabble. Okay, so let's imagine that the inverse sine of 2/5 is this number here. Okay, let's say that this is the inverse sine. So here we have 2/5, and this is the angle. Notice that the other angle is here. That is, in this case, this is the angle. So it will be pi, it will be pi, let me use red, pi minus this angle is gonna get you the other sine. So the calculator, your calculator, if you type this on your calculator, is gonna tell you this angle, theta. So this is option number 1. Use theta. So x equals pi halves minus 3 theta. Okay, that's option number 1. This is the angle that the calculator tells you. And the other option is pi minus theta. So x equals pi halves minus 3 factor of pi minus theta. You set this on the calculator, it's going to tell you the angle in radians that gets the x-intercepts. And remember that to this answer, you have to add n times the period. So plus 6n pi. Plus 6n pi. Okay? So let me know if you understand what we're talking about. Please calculate as an exercise the angles. And if you have some idea or you cannot understand, send me a comment and I can explain you how to do it appropriately. But I prefer that you do it with your calculator. I hope you took notes. I hope that you check the information. And this is the way you can sketch the graph and analyze the function. You know, in the last video we analyzed minimum, maximum, domain and range. And in this case we saw the graph. And with the graph, we found y-intercepts and x-intercepts. Okay? So I hope that you enjoyed this video. I hope that it was very good for you. Remember that anything you need, you can find me on my tube by seeing my any social network is UgoFim. You can find me there, and have a nice day. Study, and some regards, greetings to my kids that I teach. See you next class. Goodbye.